Good evening class, good evening everyone. In this video, I'm going to share to you or I'm going to discuss with you binary subtraction. Okay, the process of binary subtraction is a little more complicated than that of addition. It is the inverse operation of addition. Just in decimal arithmetic, subtraction is performed column by column. To subtract, it is necessary to establish procedure for subtracting a large from a smaller digit. The only case in which this occurs using binary numbers is when 1 is subtracted from 0. The remainder is 1, but it is necessary to borrow 1 from the next column to the left. The table for binary subtraction is as follows. Okay, so these are actually the rules for binary subtraction. 0 minus 0 is equal to 0. 1 minus 0 is equal to 1. 1 minus 1 is equal to 0. 0 minus 1 is equal to 0 with a borrow of 1. Okay, this is actually how computer works when it subtracts a number. Binary numbers can also be negative, just like decimal numbers. If a larger number is subtracted from a smaller number, the negative sign is prefixed in the answer. Okay, the following examples are given to illustrate the procedure for binary subtraction. Okay, so this time, let us follow the rules in doing this binary subtraction. Okay, so 0 minus 0 is equal to 0. 1 minus 0 is equal to 1. 0 minus 1, that actually cannot be. So, you borrow 1 to the next digit to the left. So, if there are actually 1 on the next column, you can borrow this one. This will become 0. And the 0 becomes 0, 1. Okay? So, next, actually 0, 1 in binary or in decimal, this is actually 2. So, you think of 0, 1 as 2 and 2 minus 1 is 1. Because 1 is on, 1 is off, 2 is on. That's why the value of this is 2. So that means this is, when you read this one, this is 2 minus 1. So this is 1. Okay, so let us check the binary to decimal conversion. Okay, so this is 0, 0, 1, 0, 1 is actually, so for instance, 0, 1, 0, 1. Let us write on the table. So that's actually count only the on digit. So the on digit is only 8 and 2. Meaning the value of this is 10 in decimal. So this is correct. Next, 0, 0, and 1 is equivalent to 4. So you count only the on digit. So this is 4. So 10 minus 4 is equal to 6. Okay, let us proceed to the next sample. Okay, so this time let us subtract number 2. 1 minus 0 is equal to 1. 1 minus 0 is equal to 1. 1 minus 0 is equal to 1. 1 minus 1 is equal to 0. So this is actually simple. Okay, so the equivalent of all 1 is on, this is actually 15. So meaning all the digits are on. So this is 8 plus 4, 12 plus 2, that's 14 plus 1, that's 15. Okay, check. So this one is 0, 0, 0, 1. So only the fourth digit is on. So this is actually 8. So 15 minus 8, it's 7. And this is 7. All the 3 digits are on, and on the next digit is off. So 0. So this is 4 plus 2 plus 1 is 7. Okay, so next, let us proceed to the next sample. Number 3. Okay, so let us subtract. 1 minus 1 is equal to 0 by following the rules. 1 minus 1 is equal to 0. Okay, this time, the binary minuend is lesser than the subtrahend. So, this time, 0 minus 1 cannot be. So, you borrow 1 to the next digit to the left. Since the next column and the next column is all 0, so you can only borrow 1 here. So, this will become 0. And all the zeros that is bypass, this 1, this 2 0, becomes 1. And this 0, since it borrows 1 from here, this will become 0 1 or 2. So this is actually 2 because this is binary, and the equivalent of 0 1 meaning 0 1, the equivalent is 2. So only the on digit is 2. So that's why you think of this is 2 minus 1. So meaning the answer is 1 here. Next, proceed to the next column. 1 minus 1 is 0. 1 minus nothing is 1. And 0 minus nothing is actually 0. Or without 0 is the same. Even you add all zeros here from this will not affect the value of the binary. Okay, let us check if this is correct. This is 1 1 1 1 and then 3 zeros and 1. So meaning count 32 plus this one on 2 is 34 plus 1 35. So meaning this is the equivalent 35. So all 1 is actually 15. 8 plus 4 plus 2 plus 1 is 15. So you subtract 35 minus 15, that is 20. So you check if this is 20, the answer. So okay, so let us write here. First digit is 0 0, our answer. 1, next. The next digit is off, 0. Next digit is on, and the next digit is off. So as I said, you count only the on digit. This is 16 plus 4 is 20. Okay, so there are no other on digits. So 16 plus 4 is 20. So meaning this is correct. Okay, let us proceed to the next sample. Okay, so this time we have fractional parts, meaning as part of a whole, meaning less than 1 fraction. Okay, so the same, you just simply write the numbers in column and subtract by column. So 1 minus 1 is 0. Next, 1 minus 0 is 1. Copy the decimal. Next, 0 minus 1. So, cannot be. You borrow 1 to the next digit to the left. There are no 1. This is 0. This is 0. So, you cannot borrow here. You borrow this one. This will become 0. And since this borrow the 1, this will become 0 1. All the zeros that is bypassed by the borrow becomes 1. Okay, so then you proceed. So as I have said that 0 1 is actually 2. Put that in mind that that is 2 in decimal. Okay, so meaning 2 minus 1, this is 1. Next, 1 minus 1, it's 0. Okay, 1 minus nothing is 1. 0 minus nothing is 0. Okay, so let us check. This is actually the first digit is on, so meaning count the 1. The second digit is off, so this is actually 2 because these are powers of 2. 2 here, do not count the 2 since it is off. The next digit is 4, so meaning 4 plus 1 is equal to 5 here. So how are we going to get the decimal, the fractional part of the decimal? So this is the procedure. For instance, this is how to get the 0.75 here, this one. How to solve for this, or how to convert from decimal, binary, fractional part of the binary to decimal. So this is the procedure actually. Here is the number above, this one. Okay, so just simply write the 1 here, this one, times 2 raised to the power 3. Next, so starting from 0 actually here, from the decimal point, you're going to count 0. So here, 0, the exponent here is 0, then next exponent is 1, next exponent is 2, next exponent is 3. So if there is another digit here, the next exponent for that is 4. Okay, so look at here. So from here, from 1 times 2 raised to the power 3. Next, you copy the 0 here, times 2 raised to the power 2. So the exponent actually decrements by 1. So bumaba ng 1. Next, this 0 times 2 raised to the power 1. You see, the exponent actually decrements by 1. So next, you copy this 0 again, this one, and you put it here. Then multiply it by the constant 2 raised to the power 0. Okay, it decrements by 1. This time in the fractional part, the 0.11 here. As you can see, from the decimal point here, it starts with -1. So if then the next digit, this one, the exponent is -2. So if there are 3 digits on the decimal here, if there's another 1 here, it should be -3 is the exponent, and so on. Okay, so let us simplify this one. 1 times 2, or 1 times 2 raised to the power 3. So okay, so 2 raised to the power 3 is actually 8. So that's 2 times 2, 4 times 2, 8 times 1. So this is actually 8. Next, 0 times 2 raised to the power 2. So 2 times 2 is 4. When you multiply it by 0, this will become 0. Okay, 0 times 2 raised to the power 1. So this is 2 times 0, it's 0. 2 times, 0 times 2 raised to the power 0 is equal to 0. Even in mathematics, when the number is raised to the power 0, it's actually 1. But you're going to multiply it by 0, that's why it's also, the answer is 0. Okay, so this time, here, how are you going to get this one? 1 times 2 raised to the power -1. So in mathematics, simplify that one, that's actually 1 times, write the 1 here, and then numerator, then to remove the negative, that's 2 raised to the power 1. Okay, so that's why the result for that is equal to, multiply, this is actually 2, multiply numerator by numerator, that's actually 1 over 2, or 1/2 here. So the same here, it's 2 raised to the power -2, it's actually This is understood to be over 1 to remove the negative. So, that's actually 1/4 times 1. It's actually 1/4. Okay? So, when you add actually 1/2 plus 1/4, okay, so meaning you get, so to add fraction, you just simply get the LCD of these two. So that's actually 8, the less common denominator. Then you divide it. 8 divided by 2 is equal to 4 times 1 is equal to 4. Next, 8 divided by 4, that's 2 times 1, it's equal to 2. So that's actually, addition is the plus sign. So this is equal to 6 over 8. Okay, 6 over 8, this one. So 6 over 8 is equal to 0.75 in the equivalent in decimal. So for instance, how are we going to get 6 over 8? So meaning that's 6 divided by 8 to get the decimal equivalent of that fraction. So okay, so for instance, 6 divided by 8 cannot be, you add 0, it's point. So this is 7 actually. 60 divided by 8 is 7, that's 56. 56, and this is 4. 60 minus 56 is 4, you add another 0. 40 divided by 8 is 5, exact 5. So 40, no remainder. Okay, that's 0.75, the 6 over 8. So that's how to get the decimal equivalent of the fractional part of the binary. Okay, so the same with this 0.25 and 0.50. That's actually the procedure on how to get the value in decimal from the fractional part of binary. Okay, so next, let us proceed to the next sample. Okay, this one, for instance, okay, you subtract 1 minus 1 is equal to 0. 0 minus 1 cannot be. So you borrow 1 to the next digit to the left. So since the digit to the left is 1, so you can borrow this one. This will become 0. And this will become 0, 1. So 0, 1 actually is 2 in decimal. So you think that that is 2 minus 1. So the answer here is 1. Okay, next, 0 minus 1. So again, you borrow 1 to the next digit to the left. So since this is 0, so you borrow here. This will become 0. And the zeros that is bypassed becomes 1 here. And this one becomes 0, 1 or 2. Okay, so think of 0, 1 is 2 because 2 is on. 2 minus 1 is 1 here. Okay, so 1 minus 1, it's 0. Next, 0 minus 1 again cannot be. So you borrow 1 to the next digit to the left. This is 0. And this will become 0, 1. 0, 1 is actually 2. So that's 2 minus 1. And this is 1. So 0 minus nothing is 0. Okay. So, and this is the equivalent, 53 minus 31. And that's 22. So you check if this is 22. So this is 0. You write here on the table 1, 1, 0, 1, 0. So you count only the odd digit. 16 plus 4, that's 20. plus 2, that's 22. So meaning this is correct. Okay, so that's all on how to perform binary subtraction. So if you are new to my channel, please consider subscribing, and thanks for watching.